Hi, this is Sudhir. So in today's session, I'll take you through intelligent RPA, what we can do, what are the opportunities, the limitations, and what are the best practices that we follow when we carry out intelligent RPA automations. Now, uh, so so what we have, what we do in a standard role-based automation is automating things which are repetitive in nature. Any process which is repetitive and rule-based is typically automated in the current scenario. And how the industry is currently progressing, we are looking at automating things which are not completely structured, completely rule-based, and which may need a kind of which currently requires a human intervention to be automated. The simple examples for this include automations where decisions has to be made. For example, if someone looks at the customer details and has to enter the customer details on the screen or as part of the customer onboarding, he will be able to interpret he'll be able to understand the address. For example, he can understand the country as UK and he can interpret it as United Kingdom. When we are currently doing it using a rule-based bot, we need to define rules for each and every scenario, each and every mapping. The current set of bots doesn't have the kind of knowledge required to understand that United Kingdom, Great Britain, Wales, all these refers to the same country, or at least indirectly the same country. So so here comes intelligent RPA. So this is where the bot uses machine learning, natural language processing, deep learning, etc., to understand and automate a much broader scope of processes or activities. Now, the bots in Jiffy, for example, uses say machine learning to understand what translates. The moment you see a United Kingdom or Great Britain, it automatically knows that it refers to the same country. So it basically looks at the historical information, gathers that insights and stores it, and applies that on a need basis. Now, this is a sample example of for a customer who traveled from a rule-based automation to advanced cognitive automations. So for this particular customer, when they started around 2 years ago, or rather 1.5 years ago, we started with a simple finance and accounting automation, journal voucher processes. Rule-based automation, 6,000 requests a day during the month end. Each request being processed in a specific way. The input data comes in a format or a template, and the bot takes it and carries out the same action for all the 6,000 requests. So when we automated that, the objective was basically to, let's see how much of effort we can save. Can we respond back to the customer faster? And can we improve the overall process and release the resource from the mundane work? Now, it went beautifully. It got automated in 1 to 2 months period. We were live. Now then we automated a set of rule-based processes. Then came the scenario where we are automating, but many of the processes or many of the activities falls into an exception categories, and it needs some kind of human intervention or decision making to proceed further. The simple example that we started with was again in the finance and accounting for this customer, goods receipts to invoice matching. Now, many of the goods received could not be matched to the invoices directly, mainly because the data entered by the user or the data entered or data provided by the supplier was incorrect. Now, there are certain rules that we apply. Still, a lot of these could not be matched and needed in human analysis. Now, what we did here is the first level of cognitive automation or intelligent automation, where the bot started, even though the request goes into a manual intervention, bot started giving recommended actions. So it started showing the operations user started showing this may be the potential match. Please confirm, and the bot will take it forward. So that way we reduce the effort spent on manual intervention significantly. Though only the 20% of the effort, 20% of the requests used to go into manual intervention, it used to contribute to 50% of the overall effort. And with this kind of a recommendation engine, we could bring that down drastically. Now, post this, we went into the next phase. The first phase, when we were doing rule-based automation, one of the key processes that we looked at was invoice registration. Again, this semi-structured data coming in different formats from different suppliers. Now, how do we process that? Initially, when we created rule-based bots, we used to define templates, or we used to teach the bot how to handle each specific request, how to handle each specific invoice format coming from a supplier. Now, think of a scenario when you are having 10,000 suppliers, or rather 1,000 plus suppliers. The teaching process becomes by itself a huge activity. So what we did effectively was, with a rule-based bot, we could only automate the top 30 suppliers or top 40 suppliers. Now, we put a cognitive bot for the remaining processes, an intelligent bot which could effectively understand the data within the document, irrespective of the format with which it comes, and extract the data, extract the unstructured information, and convert it into something which is more columnar and structured, which can be processed by the rule-based bot. This is one of the kind of activities that we do. So finally, the invoice, we'll go into the details of the invoice registration process, and I'll explain how exactly we went about it and how the model used to work. But finally, the next phase of automation was where we were dealing with completely unstructured information. The bot was looking at contract documents, understanding the context of the contract document, identifying which are the key clauses and which needs to be reviewed before signing the contract. So it basically used a combination of NLP and machine learning to identify the relevant context and highlight key areas for key changes in the contract when it changes hands between the supplier and the customer. So this was how the journey started. It took us probably around 1.5 years to reach at this level. But it is something which currently, in the current context, is pretty straightforward to achieve with the kind of products that we have available in the market. And this entire stack, the entire complete automation, was done on Jiffy. From the rule-based automation to the handling, reducing the effort on manual interventions, through the invoice processing, document processing, and the contract review. All the modules comes within part of the Jiffy RPA. Now, let's look at how we started with a simple, how generally the customer moves. So typically what we have seen in the market is people start with very simple automation, screen-based automation, UI automation. It could be as simple as reading an Excel file, inputting data into the ERP application or the HR application. So reading an employee detail, as part of employee onboarding, reading an employee details from a doc file and putting it into the HRMS application. Now the second phase is where we traverse multiple applications. We do complex screen-based automation, and this is where we look at scenarios like where you have to log into. One of the simple example we talk about is bank reconciliations. One of the major retailers for whom we automate, they had around 190 banks, around 190 accounts across around 130 or 140 banks. The bot has to traverse multiple bank portals, extract information, download data from distinct applications like SAP, Goods Receipt, or the warehouse application, SAP application, CRM application, do a reconciliation and upload the data. Now, the challenge with such kind of applications is that first of all you have to have a very simple mechanism to to transfer data from one application to another with limited scripting. Second is how do we manage the security? All of these are topics of interest in the standard, standard knowledge-based RPA. Now, the second kind of activity or the RPA that we do, or the automation, intelligent automation that we do in this space is intelligent bots for document processing. So, for example, out-of-the-box scenarios like the initial scenario that I talked about, like invoice processing. There are standard bots available which can be deployed and probably read context, read data out of the invoices irrespective of the format, with little or no historical information as well. So these are knowledge bots where the bot itself has the information or the knowledge to process the documents. So the moment moment a new document is received, it may not have any context, but it can still interpret what is the invoice number, what's the invoice date or amount, etc. Of course, there are productionization of it takes a bit longer than 1 or 2 days because you need to run it through, you need to ensure that the validations are in place, and you have to ensure that incorrect data doesn't go into the system. The final kind of automation that we see many of our customers moving into is intelligent process automation, where the bot not only does, it's not just about processing unstructured data, semi-structured data, it is more about self-learning bots, where the bot can learn from how the human is handling the request. It is not the bot learns what records the processes which the business operations user is carrying out. It learns from the operations user, creates the bots automatically, understands how to handle the manual interventions or the exception scenarios, and automates the process. That is the level of automation that we are currently getting into. Now, if you look at the opportunities or areas where we see the opportunities for intelligent automation, first place, of course, is an area where the input itself is coming in different formats. Input can be coming in structured format, but it could be that there are multiple formats of structured data. For example, we were automating for one of the audit firms, and they get and doing a reconciliation activity. They get input data in different formats from different customers, which we have to reconcile with their financial data. Now, the data initially may look like it is structured, but there are so many variations of it that it appears it's actually not as standard. It's not an input for a rule-based bot. And if you have to create it in a rule-based bot, you end up creating multiple or unlimited number of rules. The second scenario is, of course, where we get semi-structured or unstructured data. Semi-structured or unstructured data, for example, many times we come across scenarios where the process itself is not structured. For example, we used to get emails where the customer used to say, the customer used to receive email from a supplier stating that I have made this payment for this invoice in this bank account on this day. Now, this is completely human language, and we need to interpret it, understand the context of the intent of the email, and probably go into the financial application and carry out a transaction. So these are the places where intelligent automation plays a big role, where we can convert the semi-structured or unstructured information to a format which can be processed by the bots. Second place now that is the scope of intelligent automation in the input data space. The second area where we can significantly play, the intelligent automation can play a significant role is in the bot processing itself. You have different kinds of bot. You have self-learning bots which can learn from how the exceptions were handled historically and continuously reduce the exceptions. You have data bots where it has to deal with large amount of data and see the patterns and trends and take actions based on it. You have self-creating bots, which are bots which can track how the human user is, or human is, or the operations user is carrying out these actions, and learn from that and create the rules automatically. Now, one of the key, so that is where cognitive technologies and intelligent automations plays a role in the processing layer. Now, there is a lot of exceptions that comes through, and that is another area which is currently a lot unexplored. So we provide intelligent bots for handling exceptions as well. So for example, a request has gone for an exception. Now there is an effort involved for the operations user to spend, identify why that exception has happened, what has gone wrong, what data, probably it is some data which is incorrect. Probably as part of the employee onboarding, the project manager has probably given the cost center incorrectly. Or it may be that the employee ID itself is incorrect. So, but someone has to sit and analyze what has gone wrong, and this is where the next the assisted bots comes into picture, where the bot probably automatically sends out, gives directions in terms of what is potentially wrong and why the request has come into manual intervention, and reduces the effort spent on exceptions significantly. Now, the final portion is where the bot sends the response back to the customer. Many times, many of the automations, what we sent out as a response to the customer is always a standard response, predefined rules, predefined emails with certain fields being filled up. Now, the trend is into personalizing such requests, where a request may come where it may have multiple actions coming out of it, and you may have to merge, combine that, and give a much more personalized response back to the requester, saying that okay, I have, for example, I'm trying to process a claim request. The bot is trying to process a claim request, and the request has to be sent back to the requester. We may have to give a more concrete, rather than just saying that your request could not be processed for these reasons. We may put a more customized response to the requester, saying that we could not process this request, and it could be because of these reasons, and this may be the potential solutions for potential corrections that you may have to make before you can process this request. So personalizing the response for each requester, that is something that is probably something that the intelligent automation bot can do for you. Now, one of the key benefits with RPA, with cognitive RPA, it generally gives you much higher percentage of automation. Take this example of the earlier example of invoice registration itself. With a rule-based bot, what you typically cover is around 30 to 40% of the overall volumes. While with a cognitive bot, you are looking at as good as 70 to 85%. Now, it never touches that 100% mark, or it is really difficult to touch that 100% mark unless the inputs are really simple, because there are multiple factors involved. We'll cover that as we proceed. The second big benefit of utilizing cognitive RPA is the reduced effort that is spent on maintaining the automation. Because these are self-learning bots, these are bots which can understand how to understand actions from historical data, understand the patterns in the data. Tomorrow, if the format of the data changes, or say for example a new supplier comes in and he sends a new invoice, the effort that you spent to incorporate a new supplier into the system is much lower, because typically you may not have to do anything. You will effectively you will be able to add new suppliers into the system without making any changes to your RPA solution at all, which is significant compared to what you may have to do with each each supplier in a rule-based RPA world. Finally, the amount of insights that you get with a cognitive RPA, because the cognitive bot stores each and every details of its action on the system, which comes with a built-in petabyte scale of data storage system as well. So each and every click and action of the bot can be tracked, audited. The complete data that the bot works on can be monitored and further business performance improvements identified. Now, this is one of the key examples that we generally go through just to explain the context of how cognitive automation is different from a rule-based automation. Now, this is an example where the customer receives more than 15,000 invoices per month. Rather, we were initially piloted it on 15,000, but we had around 50,000. We had a plan of around 50,000 invoices per month. 3,000 plus invoices and around 5 entities that we are looking at. This is a very simple use case, but this may be an invoice registration use case. But this is so. Though this example is for invoice registration, this could as well be applied for any case of automation where we receive input data in a semi-structured format, in document formats, whether it's PDF text, whether it is image files, as long as the data is semi-structured. Now, when I say semi-structured, what it means is it is not, if you look at an invoice, it is not a free text. It is not a natural language or a human text, but it is more of a tabular data, but the format for it is not defined. Now, so the methodology remains the same, whether it's invoice processing, whether it's remittance processing, whether it is claims documents, supporting document validations. You could apply it to a number of scenarios within your organization. Now, when we initially started this, we put in rule-based bots. Rule-based bots, we did a volume analysis. We identified that, okay, 30% of the overall volume is coming from around 30 suppliers. So we defined rule-based bots for those 30 suppliers. Now, what do we do about the remaining 1,000 plus suppliers? And remaining 70% of the invoices are still manual. So that is where we came out with a cognitive solution, and we started feeding the bot with historical information. Now, the way it works is this. See, if you see a rule-based process at the top, so bot designer creates a template for each supplier. And based on the template created, the bot will read the PDF, extract the relevant text, and load it into the ERP. In case it cannot read, it will tag it for a manual intervention, and the operator has to manually teach the bot how to load that invoice, or in most cases, the operator will manually load the invoice directly into the ERP or into the destination application. Now, each time, the amount of automation that we typically see, the best case probably is around 45%, while the maintenance effort is more like half an hour per supplier is what we spend. Half an hour, when I say, it involves teaching the bot, testing the solution as well. While in a cognitive solution, the only thing we do ideally is take last 6 months of invoices that we have received, which typically is readily available. We load that data as well as a report from the destination application into the bot. Now the bot will automatically create a machine learning model based on this information. Now, only thing the user does is basically loading the historical data. Rest of the information, it creates an ML model. Then when there is nothing that the user actually has to teach the bot other than loading the historical data. The bot will create the machine learning model, and as new invoices are coming in, this machine learning model is applied on them, and any failures are tagged for the operator to manually load. And anything which is manually loaded by the operator is fed back into the bot so that it learns over a period of time. So the benefit with this is you are not working on the 30% or the 45% of the top suppliers. You are working on the entire 100% of the suppliers, 100% of the invoices coming in. And you are not going to really spend any effort maintaining templates. You are not worried about whether the supplier changes their template format. You are not worried about the quality of the OCR images to an extent. You are, even if the format changes here or there, the column fields changes, the layout changes, the bot still manages to read the contents, read the text out of the PDF or the image file. So this is a detailed view of how the cognitive bot works. So if you see, the first step is basically we take the historical data from the destination application. So for example, if you have an ERP, we download what are the invoice details which were entered by the user in the last 6 months. Then the next step is we take the historical invoices. We take all the PDFs which are loaded into the system in the last 6 months, the actual PDF documents. And the only thing the bot designer does is load this data into the RPA solution, into the RPA product, into Jiffy. So rest of the things are taken care by the bot. The bot will automatically tag the PDF to the SAP extract. It will generate the training data. It will generate the machine learning model. As the new invoices comes in, this machine learning model is applied on these new invoices and the data is extracted from the PDF or the image file. Now, one of the key challenges with this process is we may tag 10 invoices for manual intervention, but we can't afford even one invoice being entered incorrectly in the system. Now, if you have to achieve that, we need to have a solid validation framework where whatever data is identified by the machine learning model goes through a validation layer to ensure a sanity check, and every data which is identified by, every data extracted by the machine learning model comes with a confidence level. And we need to have a threshold in the confidence level so that anything below a threshold probably goes for a confirmation. So once all these validations are successful and the data is predicted with the right confidence level, the bot will automatically enter it into SAP or whichever ERP application it is. And in case it doesn't have the relevant confidence level, it will tag it for a confirmation, or in case it can't read the PDF file, it will also tag it for a manual intervention. So this is how the overall flow looks. Now, this is a pretty much a straightforward process. So we typically take around 1 to 2 weeks to build the model, and then probably around 2 weeks to run this entire solution over the various data, various invoices. We may have to simulate the runs. Probably we generally simulate the runs at least for 2 weeks. So what we need to really see is how does the bot behave when it comes across a scenario that it could not see in the historical data. The bot doesn't work just by the pure historical data. So it should be able to handle a combination which it has not seen historically. So does the bot work well in those scenarios is something that has to be tested. With that, I come to my last slide, which is basically around limitations and best practices of implementing an IPA solution or an intelligent process automation. The most important fact, as I was saying, was the validation layer. We put a lot of validations into the system whenever we use machine learning, deep learning, NLP concepts, because none of them are 100% perfect. Or no machine learning typically gives you a 100% accuracy or 100% guarantee. So that means you need to make sure that you have enough validations put in after the system identifies the data, just to ensure that the quality of the data that is going into the downstream application is not affected. So this may include very simple validations like simple validation like sum of line item is equal to total line item, or the distance measured between the invoice number for this supplier compared to the previous invoice number from the same supplier, are they within the threshold? So it could be complex, it could be business specific, but Jiffy provides you capability to create your own custom validations over data with minimal effort. The second major difference with the standard RPA is the duration of the project. Now, as I was saying earlier, with a standard rule-based automation, the bot always behaves the same way. Bot doesn't have to deal with scenarios that it has not seen before. But with an IPA, with an intelligent bot, what we are expecting is it should be able to even handle scenarios which it has not seen historically. So only way to make sure that the system works properly is to simulate the load and run it as a parallel application for at least for a short duration of period, so that we have the sufficient confidence level to say that, okay, it now can handle scenarios correctly. And if there is a scenario which, there is an unseen scenario which it cannot handle, are we making sure that it is getting tagged for manual intervention? Or there should not be a scenario that it is lost. It is lost in the list of requests. Now, finally, the important point is people expect bots to learn fast. So we need to set expectation in terms of how fast will the bot learn. Now, how fast a bot learns, there is no standard guidelines. It all depends on the amount of data that is coming in and amount of new scenarios which is going into the loop back feed. So sometimes the bot learns a new scenario in a week's time. Sometimes it takes a month. But that is something which is defined by the volume of data. And that expectation has to be set in the beginning, so that people don't expect that, okay, the bot will learn immediately after it sees a new scenario. It may wait for 2 or 3 instances of a similar scenario before the bot learns. So that's an expectation that has to be set. Now, finally, many of the IPA solutions require historical information. Historical information from which the bot can learn. Now, one of the challenges that we generally face is many times we don't have historical information. And for a standard domain-based solution like invoice processing, etc., we have a domain-based knowledge bot or IQ bot or intelligent bot, which typically has got a model with built-in rules or built-in learnings. But if you are coming across a scenario which is completely new and there is no predefined pre-built bot available, many times you will rely on historical data. And sometimes even historical data will be difficult to get. And you may not be able to automatically create the training data as we saw in the use case. So there may be scenarios where you have to manually tag or train the data or create the training data for the IQ bot. Finally, the last point is many places the use of intelligent or cognitive bot has to be carefully planned. Many scenarios, people tend using a rule-based bot where a cognitive bot has to be used, and sometimes vice versa. We have seen scenarios where the customer has asked us to create more than 200 rules or exception scenarios, which ideally should have been a intelligent bots automation or an IPA automation. But the challenge is many times when you start an automation, you don't know that there are so many different exceptions. And it comes evident only once you start doing the UAT and start doing the testing, that so many scenarios comes up and you start building rules one after another as exceptions into the happy path flow. So that is something that has to be probably looked at. If there are too many exceptions, probably use an IPA, and there may be scenarios where we're using hybrid approach, combining a standard rule-based automation and a cognitive automation. So these are certain criteria or certain points to be considered before picking up a solution for automation. Which way you want to do the automation, what is the long-term objective, and what are the kind of exceptions that you can expect in this automation?